long division, so I want to review some of that.
Okay, where's that start? Number 5?
Yeah, number 5.
So let's do it both ways. Let's do it by long division, and then we'll try doing it by synthetic division.
Okay.
Glad I've seen this problem recently.
Oh, you have?
I wouldn't have known how to do it otherwise. First time I saw it, I couldn't figure out how to do it.
Oh, wow.
Well, it's no big trick. It's just you have to remember to do it. First of all, if we are missing a degree of x, then we have to put in a dummy variable. In other words, suppose we didn't have that term right there. We would need to put in a plus 0x in order to do the long division.
Okay.
Okay, so always remember that.
Yeah.
And that's true whether you're doing it synthetically or not.
Yeah.
Okay. Well, this is minus 4x. You have to do the same thing for the divisor. In other words, I'm not going to divide it by x squared minus 2. I'm going to divide it by x squared plus 0x minus 2.
Oh.
And now when you do the division, the first step is always just to take this term and divide it into this term. So what do you get?
So you put the x squared?
You divide x squared into 3x cubed.
So you get 3x? So
Then you multiply 3x times all 3 terms.
on the left side or the right?
We're going to multiply this times that, and then we're going to multiply that times that,
Oh, okay.
multiply that times that. And we're going to line it up left to right. Okay? So 3x times this gives you 0x squared.
Okay.
And then we have minus 6x. With me?
Yes.
Now, just like in all long division, we're going to subtract at each step. Well, this is guaranteed to be 0 there. And now we have a minus x squared minus 0, so that just stays minus x squared. And what's minus 4x minus a minus 6x?
10.
Plus
X.
Plus 2x. Remember, we're subtracting.
Oh, 2?
Because what we're really doing is minus 4 minus a minus 6.
Okay.
Okay, and then that becomes plus 2.
Oh, okay, I see.
Okay, remember that we're subtracting this line from this line here. Okay, and then we bring down the 1, just like with regular long division, and then repeat. Do every step the same way. I'm going to divide x squared into minus x squared. It goes minus 1 time. And I'm going to multiply the minus 1 by all 3 terms.
Okay.
And then I'm going to subtract. That's my remainder. So the answer is that divided by x squared minus 2.
Oh, because that's the original.
The original divisor always goes in the denominator of the remainder.
Okay.
I got something wrong here. What do I got? No, I don't have wrong. No, I got it right. Now, if we wanted to see whether we did it right, then we would multiply this times that and add to it this multiplied by that.
Okay.
And we would end up getting this third-degree polynomial there.
Okay.
Okay.
And then is it 3x minus 1 plus 2x minus 1 over x squared minus 2, or is it multiplication?
It's plus. You always add the remainder. Unless, of course, it's nothing but negative signs, and then you could say you would subtract it.
Okay. Yeah, okay.
Subtraction is, I mean, you can add a negative. So that's the way you do long division.
Okay.
Now, let's try to do it synthetically.
Okay.
And, well, this is something I have not done. But I'm going to bet that we do it like this. Let's see if we can get the same answer.
Okay.
Now what would we do? Let's see. If I, let me think about this a second. If I multiply that back, I'm going to have a 3 and a minus 6. I'm not sure I've never tried synthetically dividing by a quadratic. In other words,
I haven't either.
Usually, okay, and that's because, yeah, we can do it, but not that way. If I was dividing by this, and I was going to do it synthetically, what would go in the box?
2?
Yes. So if I'm dividing by a quadratic, what should go in the box? The solution to that quadratic. Well, the solution to that quadratic is plus or minus the square root of 2.
Oh, I see.
So I think I have to divide by plus the square root of 2.
Oh.
And then also divide it by minus the square root of 2.
Yeah, I don't think we'll have to do that. I mean,
okay.
as long as it won't be on the test.
Notice I misread the problem. It said divide using long division on number 5 and synthetic division on number 6. They didn't want us to do this with synthetic division.
Yeah.
It's good because I'm not sure I know how to do that with synthetic division.
Yeah.
All right.
I don't either.
Well, synthetic division is easy.
Yeah. That's what I think too.
I'll tell you what. There's a tricky part to this though. What goes across the top?
One, 4, 0, -5, and 3.
Minus 2 goes in the box. What goes here?
1, and -2.
Okay. And the difference between synthetic and long division is we're always adding. Because notice I changed the sign on the number. In other words, if we were doing long division, it would be x plus 2. We'd be subtracting. The reason synthetic division works is because we change the sign on the number and we add. The fact that that's not 0 means this does not divide evenly into that. It means minus 2 is not a 0 of this polynomial. Based on the zero remainder theorem.
Okay.
Okay. So, as long as I did the math right here, did I do it right? Minus 4, 8, 3. Yeah. It doesn't come out 0. And again, this I could turn this answer into a polynomial. In other words, that's x squared. Excuse me, that's x cubed plus 2x squared minus 4x plus 3 with a remainder of negative 3 divided by x plus 2. So if I had to divide that into that by long division, I would have gotten this answer.
Okay.
In other words, after you do synthetic division, what you're left with below the line is the quotient.
Okay. Okay.
Number 7. So they want us to find p of 1/4.
Yeah.
How would we normally do it?
Use.
I would do it this way.
Oh yeah,
I would just substitute it in parentheses, and I would figure out what it is. But they want us to use synthetic substitution here, so let's do that. What it's equal to, minus 5. Let's make sure that's right. Here, before we go further. In other words, whatever that is the evaluation of it. Notice that if that final number is 0, it means that's a factor, and I should get 0 as the answer. Now this is 4 over 64 minus 5 over 16 plus 9 over 4. So that's 1 over 16. Minus 5 over 16, that's minus 1/4 plus 9/4. Minus 1/4 plus 9/4 is equal to 2. Minus 7 is minus 5.
Okay. So what would we put for the answer?
Minus 5. In other words, when you do it by synthetic substitution, it's this last number is the answer.
Oh, I remember that.
And like I said, if this was 0, then that means that 1/4 was a 0 for that polynomial, and it should be 0. In other words, if you evaluate the number at a 0, you're supposed to get 0. So whatever this comes out to be is the evaluation of that function.
Okay.
And you can kind of see that it was quite a bit easier to do synthetically than it was to do by plugging it in.
Mm-hmm.
When I plugged it in, the math was a lot more complicated. The arithmetic was more complicated.
Yep.
So we're trying to figure out whether, use the factor theorem, determine whether the first polynomial is a factor of the second. Well, what do they really want us to do here?
Use synthetic division.
Yeah, or synthetic substitution. They're actually the same thing. Okay, when they say the factor theorem, well, the other way we could do it is to say that the numerator is a factor of 8, the denominator is a factor of 2, and work through all the possibilities. But if they're asking us whether this is a factor of that, all we have to do is divide it, and if we get a 0 remainder, then it is a factor. If we get any other kind of remainder, it is not. So if we synthetically do it, which is the easiest way, you always put the answer in the box, not the factor. Or you put 0. I know you know how to do it, so I won't waste time asking you to do it here. I'll just do it. You can maybe check my answers. No, it is not. And in fact, I don't have to go very far. The moment I get to this step, I know that it's not a factor.
Yeah.
I mean, as soon as I can tell that this is not 0, it's not going to be 0.
So it isn't a factor.
It is not. If it was a factor, I would get 0 as a remainder.
Okay.
It's really it's the 0 factor theorem is what they meant. Because you have two theorems. You have the rational factor theorem and you have the 0 factor theorem. And it's the 0 factor theorem that says that if this thing is not 0, then that is not a factor.
Yeah.
The rational factor theorem would be a way to come up with the factors if they didn't give us anything at all. Of course, they haven't given us anything because we just figured out that that's not a factor. Solve the equation given the indicated roots. Okay? How are we going to do this?
Oh yeah, use synthetic division twice.
Yes. Start with the first number. Now we know it's a root, so we know we're going to get 0 here. Whoops. I do something wrong on my math here?
That's what I got. And then you bring 9 up.
I don't get 0.
Oh yeah, because you forgot the 0. There's a...
yes I did. Thank you. It's funny, I checked for it too. I just didn't see it. It does make all the difference in the world, doesn't it? Now, we don't have to rewrite everything. We're just going to divide that by that. And what we're going to have left is going to be a quadratic. So what is our answer?
X squared minus 2x plus 3 equals 0.
Well, here's the two factors. Or the three factors.
Oh, yeah. Right.
Okay? But you're right. In other words, this gives us a solution of minus 1. This gives us a solution of 3. We knew both of those solutions. And this factors nicely into x minus 3. No, it doesn't factor nicely. What am I thinking? In fact, that is an irreducible quadratic. Now, the reason I know is because the discriminant is b squared minus 4ac, and that is going to be a negative number, which means I only have complex roots.
Oh.
And usually, if you're factoring a higher degree polynomial, the books I have say you get it down to its linear factors and an irreducible quadratic. Now, if I can factor this quadratic into two real solutions, I would do so. But I just determined that I'm going to get a negative determinant, or discriminant, and so I don't take it down to its imaginary solutions. I suppose if your teacher wants the imaginary solutions, then plug this into the quadratic formula and come up with them.
Okay.
Okay? Solve the equation given the roots. Let's go ahead and come up with them. In other words, it didn't say come up with the factors. It said solve the equation. So let's carry it that final step. We know what two of the answers are. What are the two imaginary roots going to be?
3 and negative 1.
Those are the two real roots. We have to plug it into the quadratic formula. This irreducible quadratic, in order to come up with the two imaginary roots. So what would that be? Just plug that alone into this?
I ended up with 2 plus or minus 2i root 2 over 2. So then that reduces to 1 plus or minus I root 2.
It's 1 plus or minus root 2i. In other words, this converts to, that becomes negative 8. You're right, that becomes 2 root 2i. Then I divide top and bottom by 1 to get this.
Yeah.
Okay.
How come you have to have the 1 on the left side?
Because what I'm doing is dividing this fraction into two parts. In other words, I'm dividing it into that part and this part. Same way that if I have a plus b divided by c, that's equal to a over c plus b over c.
Okay.
Okay? And then the 2 divided by 2 is 1. In other words, our answer does have a real part to it. It's just a complex number. But usually you want to put complex numbers in a plus bi. Well, this one is 1 plus root 2 I, plus or minus. So A is 1, B is root 2, and then I have the imaginary part.
Okay.
Okay?
Yeah. Okay.
So what are my linear factors for number 10?
0 and -3 twice.
That's my, yeah, but what does that convert to in the way of linear factors? In other words, for me to come up with a polynomial, I need to know it's linear. It's like on the last problem, we came down to this. This was one linear factor, that was another linear factor, and we had an irreducible quadratic also.
Yeah, I get it.
Okay. In other words, they gave us -1 and 3. So now they're giving us 0 and -3. How does that convert to linear factors?
It'd be x in parentheses, and then x plus 3 squared.
Yeah. Which is what? X squared plus 6x plus 9. So there's the answer.
Yeah, that's it?
Yeah, in other words, if they gave us all of the roots, then we should have a cubic, right? Because we have an x times an x plus 3 squared. So
yeah.
we're going to have a cubic, and it's all I did was multiply these linear factors out.
Okay.
Okay? Now, the next one has 4y. So what are my roots here?
X minus 4, x plus 2i, and x minus 2i.
Good. You knew that all imaginary roots come in pairs, just like the irrational roots do. So now I just have to multiply those 3 together, and multiply those 2 together because you'll lose the I. In other words, when I multiply these 2 together, I'm going to get x squared minus 4. Excuse me, x squared plus 4. And then I'm going to multiply that by x minus 4. Come up with switch these 2 terms, and you'll have it in the right order. Okay?
Yeah, just give me
You saw how I come up with x squared plus 4 when I multiply those 2 together?
Yeah. Yep.
That's difference of squares factored. So putting it back together, I know it's going to be x squared minus 4i squared, and 4i squared becomes plus 4. All right. Ellen, I hope that's good for today, because I have a 4:30 I'm going to have to run to. So.
Sounds good. Okay. Well, thank you.
You're welcome. I'll talk to you next time.
Okay, bye.